speaking with you all. So the topic that I have chosen for this presentation is the favorite topic of the recent times, which is the EDR, Endpoint Detection and Response. So before I actually speak a bit about EDR, you know, how many of you have been to RSA last year? You can raise your hands. One. Or any cybersecurity conference, for that matter. So one common theme that you have noticed in the solutions is the EDR pitch, EDR slash XDR, and this EDR is not only limited to the endpoints like laptops or mobile phones. It has gone to the network switches. It has gone to the computes, it is now coming to all the network functions we are having for 5G. And any enterprise, if they are thinking to use a private 5G solution, so those enterprises wants to enforce security control what they are already having in their network, and EDR is one of those controls. So I feel necessary to bring up this topic into this presentation so that everyone should know that how Comcast is doing the EDR, like EDR design or the implementation, because we also are like an enterprise which are new to the telco industry. Okay. So as an agenda, what I would like to cover, I would be just emphasize on four main things. One is how would you differentiate an antivirus with EDR? Okay, like I will give you a brief overview about EDR. I will go to the EDR architecture and design options for 5G core. And when I say 5G core, it means 5G packet core. How would you architect a solution which is having an EDR on 5G core? Then I would go through the testing strategy that what we have used in the EDR deployment and how you can all benefit from that. And in the end, I'll touch upon briefly on the challenges and considerations for having an EDR. So let's get straight into it. So this is my introduction. I think Francis, you have already covered it. So if you think from the EDR, if I just, we have been have this discussion that, hey, that whether EDR is an antivirus, and how is it different from antivirus, we'll be having these questions when we bring up this discussion. So I'll give you an example. So if you are having an antivirus and it detects a malicious activity, you get an alarm to it. And what does it do? You either delete that file or you quarantine that file, and it leaves you with a log onto your endpoint. Okay. How about if that endpoint, or if the malicious activity against pops up into onto that endpoint? What will you do? You'll call to that a security operator or a security knock who has got that alert as well, and he will start troubleshooting the activity that what has gone to your endpoint. Okay, why the malicious file is coming into your endpoint. Yeah. And then he start troubleshooting, he fixed that issue, and then what happens after like a week or two, that issue appears on some other endpoint. Okay, then what will you do again? So this is what antivirus does. Antivirus checks the malicious signature and just take an action on top of it, that if it detects a malicious activity. What and how this EDR is different from antivirus is basically it gives you a graphical view of where the attack has occurred, what are the different steps that the attacker has taken, and how much it is penetrated into the network. So you will get an overview that, hey, whether my one PC is either corrupted or whether my whole network has gone corrupted. You have that graphical view coming into you. And with this, it will help you to identify the zero-day exploits. It will help you to check that if the other network gets corrupted, and what action you need to take. So it will give you a good view of the entire picture of the network. And on top of that, instead of just deleting or quarantining that file, it will isolate the process for you in some cases. So it will also be used as a preventive action, or a preventive action on top of this malicious activity. It may isolate a process, it may terminate a process, so it can take certain actions, and behind this, if you notice, we'll talk about this in the next slide, but if you notice that how it is doing the things, it is having a framework like a mitre framework, uh, in which it is actually mapping all the processes and all the activities, and then it is actually telling that, hey, this is due to the this activity, or so this is how it is doing the thing. So if you look or that, how does EDR work? So it's just the four main steps that you take. You first install the agent, or a software package onto the node. Next, when you install that package, it collects the information and reports back to the backend database. It can be an on-prem or an on-cloud database. So, like for example, if you're using a CrowdStrike Falcon, okay, the CrowdStrike Falcon has its own console, like from which the agents is sending the data to, and it is having a process view where it's checking that whether the data that I'm collecting is mapping to any MITRE framework. Okay. Next, agent detects occurrence of abnormal behavior on the endpoint, potentially uh, malicious. So what it does, uh, it will check all your system calls. So as soon as you are deploying the agent, it is hooking up onto your memory process. So every syscalls, what is coming to your kernel OS, from the user plane into the kernel plane, it is mapping all that process, and it is having that view of the system calls, that, hey, this system call looks normal versus this system call looks abnormal, and then it will take an action on top of that, as in the preventive action, that it either terminates a process, or it either detects or just give an alert that, hey, this has been caused by this and this issue. So this is how the EDR works. Now, if you look at the architecture design, this will give you a good view that if you're installing an EDR on the host, that EDR agent is checking all your calls, which is from the application which is going towards your kernel side. So any process or any action that the OS is taking, it is just checking all the calls, and this data, it is being transmitted to the cloud platform, where they are having an analysis of all these calls by using an attack framework, that that if, for example, if escalation of privilege attack happens, it has to follow certain steps, and if those steps are part of this call, and it can detect this call, then that if it's an escalation of privilege versus a lateral movement, this would give you a good view of all the process call that has been happening inside your cluster. If you look, now look at the design consideration, that so usually what I have seen is, the operators take three approaches to deploy the EDR agent. One approach is a daemon set installation, which is per node. The other option is to take a sidecar approach, in which you add a sidecar to each container. I'll go to it. I'll explain this each by one in the next slide. But just to give you an overview here, that uh, these are the different options. The third option, which is the most common one, is that the EDR usually is being installed on the host, so that it can detect all the calls. If you look at both options, uh, if let's talk about the daemon set one, which is the normal or the most common one. So what happens in the daemon set one, when you want to install an agent? Let's say if you're having, okay, in your packet core network, you're having 20 worker nodes, uh, 4 master nodes. So for each node, you have one pod for your EDR, which you will have it as a daemon pod. Okay, and this daemon pod will run as a background process. So like if you want to spin up a new node or a new worker node, that daemon set will comes with it by default. And if the worker node is deleted or reinstantiated, it will appear again. So this is like one of the models that how you do the EDR installation. Whereas the other mode is the sidecar mode. So in the sidecar one, second picture, uh, what you do, instead of having just one pod for each node, you can have multiple pods for each application. So this is slightly would give you more granularity, but it is like being used to, or it will cost like more data points for you. So you have to have a good log base where you are collecting the data. The 3 points which I like to emphasize here, that why these two options are not a good fit is why, because if you look at the human set or the site for installation, you, know, you end up having a CIS compliance. That, for example, that to deploy a cluster, you have to follow certain CIS checks. CIS are the benchmarks what operator uses to 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 check the security vulnerability of the cluster, that whether it's following all the compliance or not. So in that compliance, if you have to, for example, do an upgrade of an EDR agent, it does not let you to do an upgrade remotely. So you have to have, for example, a root account in order to do an upgrade. So this is one of the things which will prevent you to do a remote upgrade feature of an EDR. So the second mode factor is, like the second main factor is that with this model, you will be having a lot of data with you. So if you are having a good data lake or a good ingestion point where you can accumulate all this data, then it will be a good fit for you. Whereas if you are deploying agent uh, on the host side, so host is a simpler approach in which what you are doing, you are just installing when you are spinning up or doing, or you can, if you are having, let's say, 10 compute nodes or 4 storage nodes in the host OS, you can just install the agent. That is more convenient way for you to do it. It is very efficient. It comes, it supports, upgrade remotely. So, for example, if you want to upgrade that agent, you can do that remotely, and it is also give you more granularity since it is being deployed on the user space, as well as it is checking all the framework. In terms of now, we have seen that that how does, like, what is EDR, how does it work, what are the deployment options. Let's talk about the testing strategy first, because you know like for an enterprise or an MNO to use EDR, it has to make sure that all the compute layers are not having any performance issues. All the user plane communication is working perfectly. So you have to come up with something like a testing scenarios that, hey, what scenarios I should consider to install once I have an EDR agent installed. One is the asset reporting. As you are installing the agent, you have to make sure that your assets are reported to the backend where you're installing an agent. Next is detection test. So you have to know that that agent has to, once you install the agent should detect some false errors. So how will you know this thing? Because when you will install the agent will be giving the information to the backend database of the CrowdStrike Falcon or whatever the vendor that you have used. So you have to make sure that the detection test is passed. You will verify agent config review, that whether the agent is compatible with the configuration of your underlying system, whether the CPU memory load, network I utilization is as per our desired criteria. So normally what happens is uh, it, it is recommended that the agent, once you install the agent, it should not exceed like 4 to 5% of the CPU memory utilization. So this is what you need to consider. It should comes up with feature bug fix testing. It should have IOA attack calls. So anyone of you knows what is IOA? Yeah, very good. So in this one, when you detect any indicator like alert, you have to know that whether it is like what steps it is following. This is also you need to check in your testing. But then security events monitoring, that you have to like ensure that all your events are being monitored, all the like whatever data is being collected from the agent is being showing on that dashboard. Now, to start off the testing, once you have outlined all the testing scenarios, if you want to start your testing, what you're going to do is that you have to first baseline the performance. That, for example, before I install the agent, what my KPIs look like of my OS. or off by cluster. Okay, so you have to baseline the performance. Uh, okay, the next is that you have to have some post-activity performance monitoring. So once you install the agent, you check all the performance KPIs that whether it's working fine. You have to ensure that the KPIs which the EDR agent, the cloud is detecting is aligned with your console as well. So there is a possibility that once you install the agent, so since it is like hooking up in all the memory process, so the EDR console is already having that view of all the KPIs. So you can align with them that what KPIs they are having. You have to test, do some traffic load testing. So you have to do it once you don't have the traffic and once you have the traffic. And, and when I say like traffic, I mean subscriber traffic. You know, so you have to make sure that if you're installing, for example, in a compute which is having 1,000 subscribers versus 1 million subscribers, so you have to do this testing on this traffic load. And then most importantly, you have to consider the failover scenarios. The failover scenarios that if one compute is down, okay, how does the other compute reacts, and what the IUA calls that is being triggered by the agent if the failover happens. I don't want to be in a position in which, because if the EDR agent detects a failover and it detects that, for example, that hey, there is a DOS attack that happens, and it is or terminating a process. So I want to make sure that in my failover scenarios, the agent is not terminating any process and it is a normal event for me. So all these scenarios you have to consider when you are doing the testing. That's it from my side. Thank you very much. If you have any questions, please do ask me. Thank you.
So EDR for 5G core, like the requirements are unique, the deployment's unique. I imagine the threat malicious characteristics and rules are also unique. How much of the off-the-shelf EDR can be used towards that versus how much customization are you having to add?
Yeah, that's a very good question. So in terms of the customization, ideally when you talk about EDR with your management or with your architecture team, they said that no, we don't want to do this EDR. It's like a non-telco thing. It's not 3GPP certified. So, and if there's a pressure coming in that you still have to do it as part of our compliance, that you have to have some like workaround for that. So what I have experienced is that yes, there is customization that we can do in terms of when the EDR is terminating a process, that part can be avoided. So you can fine tune in which you can map only the syscalls which you want to control. Okay, and you have to turn off that mode of terminating a process. That like what you can do one. And the second point is that you can limit the C groups. For example, that this EDR agent, if it's being installed on a host, I can control that for that like processes where it gets hooked, how much CPU memory utilization that it can consume, so you can control that C group parameter, which will allow you to customize it. But whether these customization the vendor would support or not, this is something which you need to explore. Yeah.
Sorry about that. Ian Hood from Red Hat. So in looking at this interesting topic and kind of, how we kind of go do this, I kind of thought we jumped over a couple of steps in your testing phase. So before you get to test this stuff, right? So where are you confirming the repos of code that you're getting from the third party, the operating system this thing runs on, and making sure that this code is not vulnerable? It's got signed, you're tracking who's actually making changes to it, all that fun stuff before you get to test your KPIs. So is that happening before you got to this chart.
Yeah.
Just,
yeah.
you know, kind of missing that one.
Yeah. So what happens when we are getting a repo? Like for example, this package when we get, it has to go through a lot of testing, like for the vulnerability of the codes, uh, that and whether what actions we are taking on those vulnerabilities. So yeah, this is right that before the testing, I mean the code of that agent has to be tested as well. So that is a prerequisite. Yes, you're right.
Yeah, this is Young Zhao from Keysight.
Mhm.
Very interesting topic. I know in the telecom industry or 3GPP, right, we were talking about from threat detection, monitoring, and things like that. And I know CISA also have a guidance what telcos call for 5G.
Mhm.
The approach is more about observability. Basically, you get the traffic, get the data from each of the network functions because in 5G core networks, all the network functions are coordinated. This is not like your typical IT network, which you have a host, they just work on their own, right?
Mhm.
So I think it's more a clarification question. I I want to understand when you talk about EDR more on the host levels,
Mhm.
not at the application level. If you talk about application level about control plan, data plan, those kind of stuff, I think you probably have to have a more observability built into the code of the network functions, and then have a central function to kind of coordinate and then detect on a per endpoint base. I think it would be really a challenge to kind of really give you a more insightful information. At the host level, I think, yeah, that's probably a very good idea. Do you agree on that approach, or you're really looking at EDR?
Yeah, so we are taking like different approaches. So all the three options, like what I have shown you, has their own pros and cons. Yeah. Uh, what I have experienced is if you're doing on the application side, you'll get more data from the applications, and but the downside of that is, I mean, the part where it is, terminating a process, so that part is still we have not explored completely, so that is still under the testing phase. But like my idea is that uh, okay, we have to architect a solution in which we have to have an hybrid approach in which some like agent goes to the application side and some goes to the host side, so that we can have a balanced view of the network. Yeah. Yeah. Thank you.